All right, guys, so you were watching this play. Pause it if you did not join the live Zoom. Sorry, I got up a little later than usual today, but this is what you need to watch if you missed the live Zoom for class. I'm going to be doing these play posits after A day, before B day, because I will then know kind of the questions that are coming about with this topic that students are asking and any announcements that I seem to find throughout the day. You are going to have a quiz if you're a B day on Thursday and if you're an A day on Friday, and it's going to be over everything that we learned before fall break. So the homework for tonight that is also linked in KIDM, where these guided notes are also linked, is to study for that quiz. So if you're having problems with that, you need to join my Zoom call in the mornings to get some help. All the videos for previous lessons over teaching all that stuff are also here on Play Pause It. So use that to get some help, maybe if you haven't learned it yet. But today, what we are covering, let me make sure there's anything I need to tell you. I do believe so. Okay. Today, what we're covering is factoring using GCF and grouping. So our objective here is to factor quadratic expressions using the greatest common factor and grouping methods. So the first thing that we're going to go over is our greatest common factor and what that is. So the greatest common factor is the greatest constant or variables common to all terms in an expression. So we're going to come down here and we're going to find the greatest factors of these examples, and we're also going to factor them. So whenever we are finding our GCF, so for example, if we're looking at that example 1, we're looking at 14 and negative 21x. We are trying to find the biggest number that is a factor of both 14 and 21. And hopefully y'all remember from last week when we did little factors, or we did factor trees. So if we're looking at 14, we're looking at like 2 and 7. Some more factors of 14 are 1 and 14. So it's things that you can multiply together to get that number. So 14, it has 2 and 7 as factors, and 21 also has 7 as a factor because you can do 7 times 3. So the greatest common factor here for both of those is going to be 7. And also another thing you can do, let's see if I can find my calculator to show you how to do it on yours. So if you have access to a graphing calculator, I'm going to show y'all how y'all can go about finding it. So you will come over here to this math button that's below alpha, and you'll click on that. And the buttons I'm clicking are down here as well if you need to see them. And I'm trying to kind of circle them around on the calculator so again, you can kind of see what I'm talking about. You're going to want to click over so that you're on the number screen. I believe whenever I click it on my actual calculator in person, I don't see all the way down to number 9. So you may have to arrow down a couple times and hit enter. Or you can also just click Math 9 and GCD pulls up. And the numbers that we were looking at was 14. So you're going to type in a 14. And then this comma here that's between the x squared and the parentheses, you're going to need to know where that is. And then 21. It is negative 21 in the problem, but we are just going to type in positive 21 in the calculator so that it'll give us an answer. And then you close out your parentheses and then you hit enter. And as it also tells us, which this is greatest common denominator, but it's still giving us that 7 because that is the greatest common factor here. So 7 is correct for there. So if we're looking, do they both have x terms? And the answer here would be no, because we're looking at 14 minus 21x. So there's not an x term on that 14. So therefore, our greatest common factor of both of those terms is 7. So then we're going to come down here. We're going to divide each term by the GCF to factor it out, which that's the next step, is to divide out the GCF of each term. So we are going to rewrite this as 14 minus 21x. We're going to divide 14 by 7 and 21 by 7. And hopefully you would get that it is 2 minus 3x. So whenever we go to write our final answer for this, we need to write our greatest common factor outside the parentheses and whatever is left on the inside. So our final answer here would be 7, 2 minus 3x. And that would be your final answer there. And why I am thinking about it, something that I reviewed in class with the students is, let's give us a number, we'll use 7x to the fourth. And we kind of went over what each of those things is called. So the 7 out front is your constant. Your x is your variable. And your 4 up here is your exponent. If you do not remember that, I strongly suggest trying to figure it out before your quiz because there may be a question asking about a constant or something like that. All right, so now let's look at, and 14 here is a constant. A number can have no variable and it still be considered a constant. So if we're looking at number 2, is there a number that's a factor of 3, 9, and 12? So you can do the math in your head and hopefully you can figure out what the factor is. But I am going to show you on the calculator how you would do a problem like this if there was 3 terms in it. So you would again hit math over, and you can either scroll down or you can hit the number 9. And we're going to do 9, 3 first. So, and the greatest common factor there is 3. So I'm going to go ahead and math number 9 again. And then we're looking at 3, because that's the greatest common factor between 9 and 3, and 12. And the greatest common factor between 3 and 12 is 3. So the number that's a factor of all of those is 3. You cannot put 3 numbers in a calculator. You can only put in 2 at a time. Do all 3 terms have an x? I hope that you see that there's an x to the fourth, an x cubed, and an x squared. Therefore, yes, they do. What is the greatest number of x's that all 3 terms have? So that's kind of confusing, but what it's really asking is, so we have x to the fourth, x cubed, and x squared. So they all have at least 2 x's because of this x squared right here. So you pretty much pick the x with the lowest exponent because this has at least x squared, this has at least x squared, and this has at least x squared. So that's kind of what that question means, because that means that we can pull an x squared out of each of those terms. All right, so therefore this time our greatest common factor is going to be 3x squared, because we can pull out a 3 and an x squared from each term in this problem. So we are going to rewrite the problem. So we were looking at 9x to the fourth plus 3x cubed plus 12x squared. And I'm going to scroll down a little bit. And we are dividing 3x squared from each of these. And I'm going to go ahead and write my answer, 3x squared, because remember, we always got to write our greatest common factor out front. So hopefully you recognize 9 divided by 3 is 3. X to the fourth divided by x squared is going to leave us with x squared. Hopefully you remember from exponents that if you are dividing, you subtract. So 4 minus 2 is 2. 3 divided by 3 is 1. X cubed divided by x squared is going to leave me with an x. 12 divided by 3 is 4, and x squared divided by x squared is going to cancel out those x's. So that means our remaining is 3x squared plus x plus 4. And that would be your final answer there. All right, we're going to go down here and work some more example problems. I'm going to have you figure out the GCF of each of these and have you input it. And then I will help you pull out those terms. All right, so for number 1, hopefully you got that your greatest common factor was 6. So you're going to do 6x minus 18 divided by 6 divided by 6. And you'll be left with x minus 3. I am kind of going to go a little bit fast through these because this is just simplifying it out. So you're finding your greatest common factor, you're dividing the problem by it, so each term by that greatest common factor, and rewriting it. If you're struggling with this, I would probably join my Zoom call in the morning. Hopefully you got that the greatest common factor for number 2 is 4. And so whenever we were looking at this, you're going to do 8 minus 4y divided by 4, rewrite 4, 2 minus y. Your greatest common factor for number 3, hopefully y'all got 2x. So you're having 2x minus 4x cubed divided by 2x divided by 2x. So we're going to rewrite 2x. 2x divided by 2x is 1. You got to make sure to remember that 1. Yes, the x's cancel each other, but 2 divided by 2 is still 1. And then 4 divided by 2 is 2, and we will have x squared left. All right, and on the next page, there's plenty more examples. So the first thing that we're going to look at, again, I'm going to have y'all actually find the greatest common factor, and then we'll come back and go over it together, and I'll help you pull out some terms. All right, number 4, hopefully you got the greatest common factor here was going to be 4. And when you pull out that 4, you're going to be left with x squared minus y squared. Your greatest common factor for number 5, hopefully you got p. So you're pulling out a p, you're left with 1 plus rt. Number 6, your greatest common factor, hopefully you found, was 4. And so when you pull out a 4, you're looking at 3 minus 2x. I'll go over the greatest common factor for number 7 with y'all because this is where they get a little complicated because you got to check for multiple variables. So whenever I'm doing these, I like to kind of do it piece by piece. So the first thing that I look at is the numbers. So we're looking at 21 and 14. Hopefully you recognize that their greatest common factor is, again, going to be 7. And then we have to look at the variables. And I see 2 variables. I see an r and an s. So for that r, I see that I have r cubed and r squared. So I know I'm going to be able to pull out r squared of each of those. And then when I look at my s's, I see s squared and s. So again, I know I'm going to be able to pull out at least one s. So that's how you get your greatest common factor with those. I really recommend going piece by piece through the problem. So once you pull out that 7r squared, you are then looking at 3rs minus 2 as your final answer there. Your greatest common factor for number 8, hopefully you found that it was 3cd. And once you pull that 3cd out, you're looking at 2c squared minus 4cd plus 1. Your greatest common factor for 9, hopefully y'all realize that is x. Once we pull out an x, we're looking at 16x to the 4th plus 12y minus 9y to the 5th. Some students in class were thinking that 3 would have been a number that we could have pulled out. 16 is not divisible by 3. And others were thinking, I think it was 2. And you cannot pull a 2 out of 9. So it has to agree with every single term in the entire problem. That was a little bit of a problem in class. All right, so now we're going to go over some factoring by grouping. I'm going to show you all this box method. If you are a very, very visual person and can be very, very careful, you can use it. I recommend using another method that I'm going to show you once I finish the box method. And then I kind of recommend using the method that I use, but you can use this box method if you're very visual and like it. But I'll do the first problem both ways, but the rest of them I'm just going to do by the grouping method that I do. So first you're going to draw a 2 by 2 box, which is already done here. Something very, very important is always check to see if there's a greatest common factor first. So whenever we're looking at this example, a cubed minus 3a squared plus 3a minus 9, is there a greatest common factor? Hopefully your answer is no. There's no numbers that you can pull out because there's understood to be a 1 out here in front of that a, And there's no a with that -9, so we can't pull anything out. So the next step was to put the first two terms across the first row and the second two terms across the second row. So what that means is you're going to have an a cubed here minus 3a squared here, 3a here, and -9 there. So for the next step you're going to do is you're going to pull out a greatest common factor from each column in a row. So if we're looking at this column first, is there a greatest common factor between a cubed and 3a? Hopefully you recognize that you can pull out an a of both of those. And then let's go ahead and look at this column as well. So we're looking at -3a squared minus a. So we can pull out a negative here because we have a negative times a negative. And we can also pull out a 3 here because 3 is a factor of 3 and 9, and it's the highest factor we would be able to pull out. We cannot pull out any a's because -9 doesn't have any a's. So now we're going to look at our rows. On the top row, you should be able to pull out an a squared. And on the bottom row, you should be able to pull out a 3. If you are struggling with these greatest common factors, again, please let me know because I would love to help, but I'm not going to go through it on every single problem in major detail. All right, so then it says the next step is answer is the terms on the top and on the right, which I did the top and the left, because at this point you could check to make sure that your answer is correct, because you're pretty much checking the box multiplication. So a squared times a is a cubed, 3 times a is a, -3 times a squared is -3a, and -3 times +3 is -9. So that means that our final answer here would be a squared plus 3 and a minus 3. So that is one way that you can do it. I'm going to zoom in or like close over here so that I can write super largely. And I'm going to show you another way. I'm going to do the second way in some green just so that y'all can see the difference. So we're looking at a cubed. I'm going to make this smaller too. So we're looking at a cubed minus 3a squared plus 3a minus 9. So, and whenever I'm doing this, the first thing you're going to want to do is draw sets of parentheses around the first two terms and then a set of parentheses around the last two terms. No matter what, your sign right here has to be positive. I will show you in a minute what you have to do if it is negative. So once you have your first two terms grouped and your second two terms grouped, you're then going to look for your greatest common factor in those groups. So if we're looking at a cubed minus 3a squared, we can pull out an a squared out of both of those because it would be our greatest common factor. So what's left in there is a minus 3. If we look at our second group of parentheses, the greatest common factor there would be 3. So we can pull out an 3 and we're left with a minus 3 on the inside. It is very, very important that what is inside these parentheses matches perfectly, because if it doesn't, you can't keep going. So at this point, you are going to rewrite this as your greatest common factors as their own set. So we're looking at a squared plus 3. And then you write what's in your parentheses because they're the same thing, but you're only going to write it once. So a minus 3. And if you would like, you can multiply those binomials out and see that you will get the exact same answer. But that is your final answer there. It's got a few less steps, which kind of makes it nice. Because see, we got a squared plus 3 and a minus 3. So for number 1, I'm going to do both ways. So I'm going to kind of zoom in again. The first way that we're going to show you is that box way. This is where you have to be very careful, and it's because of the negatives in this problem. So we're looking at 2x cubed minus 3x squared minus 4x plus 6. So if we're pulling out a common factor here, and we're looking at, let's do our columns first. We're looking at this first column. The first thing that we're going to be able to pull out is a 2x. Because 2 and 4, we can pull out a 2, and then x cubed and x, we can pull out an x. If we're looking in the second column, if we're looking at 3 and 6, we can pull out a 3, and then x squared is the only variables in that column, so we're going to leave it as it is, okay? So let's now then look at our rows. And this top row, we can pull out an x squared. In this bottom row, you can pull out a 2. See, now like the complicated thing here though is if whenever we look up here, we had a negative and a negative here. So we could pull out a negative with that 3 and we still got the right answer. The problem here is because you got to go back and check to make sure that you can multiply these two things to get this answer. You cannot multiply x squared and 3 to get negative 3x squared. So you're going to have to put a negative here. Because again, same thing down here. 2x times 2 is positive 4x. So again, we're going to need a negative here to get that negative. So the kind of crazy thing here is because this is positive and these are negative, is why we have to have a negative here and a negative here. This is where it gets very kind of confusing, and you got to be very careful with those negatives. It's a lot easier whenever we go in and group it. So let's go ahead and write our answer down here. So we were looking at x squared minus 2 and 2x minus 3. That is our final answer here, but I'm going to show you how much simpler this is whenever we just go in and group it. So whenever we go in and group this one, which I'm going to rewrite it because of that minus sign that's right here, because remember, we had to have positives in between our groups. So I'm going to change this to a positive, and I'm going to leave my negative with this term. Okay? So now I'm going to look at each of them, and I'm going to, again, pull out my greatest common factor, which is kind of a little bit easier now, especially because I already have the answer too. So we can pull out an x squared in that first set of parentheses, and then we're left with 2x minus 3. And then whenever I come over here to this problem, so remember what I said earlier, that what's inside has to be the same. So I'm going to ignore that statement for a fact and show you where you could make a mistake. So I see that we can pull out 2. So I'm going to pull out a 2, and I'll be left with negative 2x plus 3. So here, our signs are opposite. So it's not the exact same thing. So we made a mistake. But because those signs are the 2 is opposite and the 3 is opposite, I can pull out a negative and change all of those signs. Ooh, not that one. We want that one to stay minus. So if I pull out a negative 1, that's going to change that negative 4 to positive, and that positive 6 to a negative 3. So therefore, now we have the exact same thing inside our parentheses, and it's a little bit easier to check that here than it is with the box. So we would then go to write our final answer, which would be x squared minus 2 and 2x minus 3. And we got the same answer both times, so we're good to go. I'm going to do the grouping method for a majority of these, but if you like doing the boxes, you can, just like I've said, be very, very careful. Let's do this one in purple. So we're looking at y cubed plus y squared, that plus sign, but that minus 5, minus 5y, minus 5. All right, so in my first set of parentheses, my greatest common factor is y squared, and you're going to be left with y plus 1. So over here, again, I know I need y, so I can recognize that I need to bring out a negative 5. So we'll have y plus 1. So our final answer will be y squared minus 5 and y plus 1. There you go. So let's come down here. Look at number 3. So number 3 is kind of a little bit easier because we have a positive here. So we can just go ahead and draw in those parentheses You don't even have to rewrite it. All right, so I'm going to be able to pull a 2x out of that first set, and we're going to be left with x minus 5. And on the second set, I'm going to be able to pull out a 3, and I'll be left again with x minus 5. I forgot my 2x squared, sorry. So 2x squared plus 3 and x minus 5. And that is your final answer. All right, on number 4 again, I'm just going to go ahead and draw these parentheses up here because, again, we have that plus sign between those two little sets, we can call them. I can pull out a 5x squared out of the first one, and I'll be left with x minus 1. And I can pull out a positive 8, and I'll be left again with x minus 1. Giving me my final answer, 5x squared plus 8 and x minus 1. All right, so let's zoom out a little bit and go on to the next page. I'm going to have y'all go ahead and give me the answer for number 5. Again, it's the same thing that it's been. You're going to group them, pull out your greatest common factor, and then rewrite your answer. All right, so hopefully you grouped these two together, pulled out that x squared, and was left with x minus 2, plus 5 you can pull out, and x minus 2 again. And hopefully your final answer was x squared plus 5 and x minus 2. This one's a little bit more complicated, so I'll kind of go through this one step by step with you. I'm going to rewrite this one. So again, we are looking at 7a. Actually, I'm not going to go in purple. I'm going to do it in green because it's skinnier. Oh gosh, y'all ignore me. So we're grouping 7ac squared plus 2bc squared. We're going to change that to a positive. Keep that minus with that 7ad minus 2bd. So now we're going to look for our greatest common factor in our first set. So 7 and 2, their only common factor that we can pull out is a 1, so we're just going to kind of leave it as it is. The only common variables that they share is that c squared and c squared, so we are going to be able to pull out a c squared, and you're left with 7a plus 2b. Over here again, so 7 and 2, or actually negative 7 and negative 2, we can pull out a negative 1 here. So I'm going to change that to a negative, and I'm also going to pull out the d because that's the only variable they share. So I'll be left with 7a plus 2b, giving me my final answer of c squared minus d times 7a plus 2b. So it looks very complicated and scary, but again, it's the same thing. Just take it piece by piece. I also had some TN Ready practice problems down here, but all I'm going to do today with them is pull out the greatest common factor. We're going to come back and look at these later, but see if you can find the greatest common factor for number 1, and then when you come back, I'll write it. All right, so your greatest common factor here should have been 3x cubed. And then we are going to look at number 2, which has moved way down. And I want you again to find the greatest common factor here. And hopefully you recognize that that is 4. So that is it for the lesson today. Your homework is also linked as a PDF in Kidem, where these notes are as well. So go ahead and get that done and submit that into Seesaw. The title of the homework is the exact same thing in Seesaw. If you have any questions, let me know. And do not forget about your quiz that's either on Thursday or Friday.